All right, we're going to work through this activity for students that might be working from home. This is activity 115, Gears, Pulley Drives, and Sprockets Practice Problems. This is intended to be kind of a reteaching for those of you that have turned this in, but maybe had questions somewhere along this activity, and you're needing to see solutions and get an explanation. All right, so for the first set here, we are going to sketch and annotate. We have gear A as the driver with 8 teeth. Gear B has 24. So A has 8, B has 24, and C has 16. And I'm going to be writing this out. So just to annotate, I'll draw a smaller circle, right, for a gear that would have 8 teeth, and a bigger circle for a gear that would have 24 teeth, and one that's in between those two sizes for a gear with 16. So we've got A, B, and C, and we could write, n equals 8, n equals 24, and n equals 16, just to annotate. Let's see. Okay, number 2. It says, if the output is at C, what is the gear ratio? Okay. So calculating gear ratio can be done if we can compare either the diameters, the teeth, those are physical attributes, or even attributes of while they're in motion, which would be the torque and angular velocity. In this case, what we have to work with is the number of teeth. So as long as we're comparing apples to apples, teeth to teeth, then we can do this. And the gear ratio in a simple gear train is really the number of teeth of the final output gear divided by the number of teeth of the input gear. Okay, and that really comes from calculating gear ratio is technically equal to the product of all these gear ratios where all the teeth mesh. And remember, it's n out, number of teeth on the output gear, divided by the number of teeth on the input gear. So all of these gear ratios from A to B, it's number of teeth on B over number of teeth on A, and then also the number of teeth on C divided by the number of teeth on B. And then you find all those gear ratios and you multiply them together. Well, in a simple gear train, it just so happens that you're always going to get all the idler gears to cancel out, be common factors from the top and the bottom that will cancel, leaving the final output gear as the only factor in the numerator and the original driver as the only factor in the denominator. So this is our shortcut. So in this problem, we would say that gear ratio is equal to the number of teeth from gear C, which was 16, divided by the number of teeth on gear A, which was 8. So we get a 2-to-1 ratio. It could be written like this. So that was number 2. Number 1 was just to annotate. All right, moving on. Number 3 says, if gear A rotates at 60 RPMs, how fast is gear C rotating? So for number 3, I'm going to write that the angular velocity of A is 60 RPMs, and they're asking us to find the angular velocity of C. I did copy that down, right? Correct? Yeah. Okay, so what you need to know is that the gear ratio is equal to the ratio of the angular velocities with the input over the output. So in this case, our gear ratio of 2-to-1, or where does gear ratio come from? It came from our gear ratio, the ratio of these teeth, right? So you could even write it like this. The ratio of number of teeth on C to A was equal to the angular velocity of the input gear at A and the angular velocity of the output gear at C. Okay, so we already know that that's going to be a 2-to-1 ratio, and here we had A at 60 RPMs and C, the angular velocity, it's this lowercase Greek letter omega, as the unknown. So this is our equation, and now we're going to solve it. And it's really just a proportion. So easy thing to do when you have a fraction equal to a fraction is to set the diagonal products equal. So that means the product of 2 times the angular velocity of c is equal to the other cross product, which is 1 times 60, which is just 60, right? So we need to solve for the angular velocity at c, which means we need to get rid of that factor of 2. And how we're going to get rid of the factor of 2 is we are going to divide both sides of our equation by 2. That'll cancel out that factor of 2, and we will get our final answer. The angular velocity of c, 60 divided by 2 is 30, and the units is RPMs. All right, the next question, number 4, says if the output of torque at gear C is 150 foot-pounds, then what was the input torque at gear A? So number 4, torque at C is 150 foot-pounds. Question is, what was the input torque at A? Okay, with torques, it is the ratio of the output torque over the input torque that is equal or equivalent to the gear ratio of your gear train. So in this case, we still have the same gear train, so we're still going to have the same 2-to-1 gear ratio here. That is going to be equal to our output torque at C over the input torque at A. So substituting in the number they gave us of 150 foot-pounds, we'll have 150 over the unknown torque at gear A. Again, we have a proportion, and we can just cross multiply, which is setting those diagonal products equal to each other. So 2 times the torque of A is going to be equal to 1 times 150, which is just 150. Okay. So we got 2 torque at A, trying to keep it color coded. And then lastly, we want to solve for the torque at A. So we're going to get rid of this factor of 2 by dividing both sides by 2. And we get that the torque at A is equal to 75. And that'll be foot-pounds. I think that's the last question for this section. Yep.